Okay, let's look at another one. Let's find the electric field at a point P. So find E at point P. Um, if and this time, again, thin rod. I just want to make it look a little bit thick. And point P is right over the center point. So I have charge smeared all along this thin line. Point P. Nice positive charge. So a piece of positive charge over here is going to create an electric field that's directed boop, like that. But its symmetrical piece over here on the far right is going to create an electric field that way. And then there's the next one, and the next one, and the next one, and the next one. So what do we wind up seeing? What's going to happen to our total electric field? Our net electric field is equal to just the electric field in the y direction. So a couple things that we know. We know that we can find the net electric field vector by summing up all the contributions of all the electric fields due to the little charges smeared along this length in a particular direction. Now I know that lambda is Q over the length. I'm going to call that L if you want to. So that makes it dq proportional to dl. And which would be the same as saying that dq by dx. You guys seem to like x's better when it comes to that. Okay, so let's define the distance from point P to our long, uniformly distributed charge rod of science as being D. The length of this rod guy is L. That's the ugly bracket right there. So that's L. Now let's look at a bit of charge. And let's look at a bit of charge right, oh, I was going to use a color or something. Let's look at a bit of charge right there. Little bit of charge at that point right there. That little bit of charge is a distance from point P, R. And it's a distance from here, from the point where P is right over the rod of X. So now what's the distance from dq, this little bit of charge, to point P? R squared would be equal to x squared plus d squared. Now my dq would be the same thing as lambda dx. So I have an expression for dq. I have a relationship for r, and my r hat should just be y hat. And what's y hat going to be for straight up? 1. So let's make our substitution. So Coulomb's constant, dq is lambda dx. R squared is x squared plus d squared. And r hat would just be 1. R hat is Y hat, and it's 1 because only in the Y direction. All right, back up. Let's look at this Y. The angle is actually changing. And so the Y component would be the sine theta. So instead of 1 here, we're going to put in sine theta. And actually, sine theta would be, let's go back and look at our triangle here. Sine of, so if we're looking at this guy right here, sine theta there, isn't that angle the same as that one right there? Not that one in particular. Hold on. Let's see. We'll pretend like, there we go. So sine would be opposite d over r. Okay. So that would be d over r. So let me make that substitution. But r, oh man, isn't r like the square root of... So here for my y hat, or my r hat, which is actually y hat, which is the y component, but the angle is changing, so I need to take into consideration the angle is changing. And I'm going to have a weaker electric field at a different distance. So this would be d over the square root of x squared plus d squared. Which is not a trivial integral. Would that be x squared plus d squared to the 3/2? Now you probably want to look at an integral table. I looked it up in an integral table in a textbook over there in my cabinet, and you wind up with k lambda d x over d squared times the square root of x squared plus d squared. What's important? Being able to set it up. Please don't go through the trouble of memorizing that integration. When we simplify it out, we'll have what? K lambda d. Oh, nope, that's not. We'll have x over d squared times the square root of L over 2 all squared plus d squared minus x over d squared, the square root of negative L over 2 squared plus d squared.
That's what I got.
All I did was substitute the L over 2 and negative L over 2 for x here. So I'll have k lambda d Okay, then I think this does simplify correctly to something that works for us. Yes? No? Maybe? So we have what? L over d squared, square root. Can I call this L squared over 4 plus d squared? Thanks, Shelly. I could actually cancel a D and a D square here. And that winds up being in the right form. So that makes me happy. Because this would be a distance. That's a distance. Squared. No. Well, I was done with my derivation, so I put a